Hello, welcome back to an overview of AbLead, an antibody analysis and engineering suite. In this video, I'm going to show you a few features that will help with selection, analysis, engineering. The first one is one that's called a mutation grid. If you've built engineering variants, and I can show you here that it created a couple of variants that were humanness variants as well as stability variants. This is an isomerization site that I chose to fix, and I built these out as variant designs. In this example, there are two positions that are the missing salt bridge at the base of heavy chain CDR3, and I reinserted that salt bridge. So if you look across here, you can see in the engineering 9 example, we've modified the humanness and made other repairs. These weren't all humanness. One was a stability violation repair. And if I scroll back, you can see that in the stability, these had an impact in the stability. And in this case, this was a repair of that missing salt bridge. It's missing in the parental molecule and now repaired in the engineered variant. But if I wanted to see these quickly, I could just be lazy and select everything and come in here and select mutation grid. And it populates a grid based on the parentage. You can see that in this set, the parentage was automatically assigned when I built engineered variants for these. The engineering tool knew which molecule was the parent, and so it set the parent lineage right inside the tool. And that mutation grid then shows the modifications that were made from the parent. These can be exported as grids for an ELN or for a report. So pretty easy way to see what modifications have been made across a molecule. There's other uses for this. You could set the parent of a molecule artificially, and just if you wanted to see what the difference between those were, you could see those. I would use the alignment tool that I showed in an earlier video, but that is one way that you could evaluate the difference between two molecules. I just cleared that parent. So another feature to see here is one that's called observations. As you're doing work, these are all fake. I've entered in just for the demo purposes of the demo. You can look across to see if there are any positions, residues in specific chains that had attributes that you've noticed in other projects. And I'll show you an example of this. I'll just select the 15 that are the main molecules. And I'll go into an analysis tool just to try that. Any tool that allows for engineering on a residue will show these. And you can see that here at position 114, I'll just zoom in here so you can see this. There are positions with little dots over them. Those are indicating that that position has an observation or a mutation design based on its color. But if you click on it, you can click on observations and see that if this is a tryptophan, it did indeed have oxidation and degradation. Oh, and by the way, if this position were a cysteine, it forms a disulfide with position 110 of the same chain, if that's also a cysteine. So it's nice to be able to add and view observations from previous engineering and analysis runs. The other thing that can be done that I'll show quickly in this tool is physical properties. These are only really believable if you have full-length sequence entered. Leader sequences are ignored, they're trimmed off, but you can get a view of the PI, the extinction coefficient, percent extinction coefficient, average of monoisotopic mass, and the Gravy score. You can look at the help documentation for an explanation of these. You can reduce or non-reduce these to break any disulfides. And you can also trim to the FV if you'd like to and do these in combination. You can also set the stoichiometry. In this case, I know that these the light chain and the heavy chain each have a stoichiometry of 2. and so they're set by default. And this can be exported as an Excel file. So those are a few other properties that are easy to visualize in terms of engineering or using the molecule. But one last attribute that I'll show in the tool for grouped molecules, you could do this singly or as a group, is a clinical comparison. And what I've done here is run the Jane 137 molecule set through my tool set to evaluate scores based on that clinical comparison. So there are 127 human molecules in the Jane set, 137 total, 10 of them are mouse. And so there's a checkbox that you can check if you want to evaluate against the human only scores. And I do have a note here that just because an entry falls within the guidelines of what was seen in the clinical set, it doesn't mean it's going to be easy to take it through process development. This just lets you know that it's in line with a clinical set or not in line with a clinical set. So you can see where you have CDR outliers. This germline was never seen in the clinical set. Outliers in stability, in unusual cysteines, and so on. So you can screen across your set of molecules to see how it behaves against the clinical set as published by Jane et al. You can export this as an Excel grid, of course, and it looks just like this. One other attribute that I'll show you is done on a single molecule, and it's incorporating the Oxford Protein Interest Group protein or patent and literature antibody database search. This uses the data sets from that OPIG tool, but does it all internally, so you're not putting your sequence up into a non-private cloud. I don't think that they would use or share your sequence in any way, but if you want it to be internal, here it is internal. One caveat, I have it as a disclaimer, is that this is only searching sequences that have been extracted from NCBI. There are sequences in the patent literature that aren't in NCBI, so you'll want to reach out to an attorney to make sure that your sequence is actually patentable. But this helps with a quick look to see if your light chain has high identity to other molecules or your heavy chain has high identity to other molecules. And if there's an entry that has both your query light chain and heavy chain, it would show up with a view here of LH. You can set the region that's used. I'll set it to just CDR3s and run this, and you can see in the light and the heavy chain the CDR3, and it shows here what residues were used to make that determination. Any of these are clickable, so if you click on this, it will take you to the NCBI entry for that hit. So that's it for this video. I hope you've enjoyed this, and I'll see you in the next one for a few more engineering tools.